In here, we are going to write program, and this will be the different aspect we are going to see. In server, we have socket. We'll create a socket, then we'll bind it. In client also, we are going to create a socket and we are going to bind it. Bind means we are binding it with this certain port numbers. Every system has a port number linked with certain services or process or application. Then if you see, neither we have a connect or a listen. So listen and accept is not there. That is what we saw in TCP. Listen and accept will not be there. There is no connect on the client side also. Only socket, creation and binding with port number. Finally, receive and send from both the parties will be there, and then close. So this will be the program we are going to see. So one by one we are going to see that. This is Linux environment. You have to do it in Linux. And in this Linux, what we are going to do. So first, this is UDP client server program. So take any folder, or rather you can make a new folder. I'm making a new folder, and this I'm naming as UDP client server. UDP client server. This is just a folder name. And here we are going to make two files. One for client, one for server. One for client, one for server. So two text file you are going to make it. If you want to make it in code blocks or any other, say, IDE, you are most welcome, and you have to execute it, but I'm doing it using the command line and normal editor. So I'm making a file inside this UDP client server, and I'm naming it as one will be UDP. I'm just creating it. I'm not writing anything, just creating it. UDP server .c. This will be our server file, or you can say datagram server. So .c will be the C file. Okay, now we just save it, and you can minimize it because I'm going to make one more file here. And you don't need to make this file here only. Wherever you want, you can make the file here and there, any other location, but I'm trying to keep it here for ease. So now I am going to make a file which is UDP client.c. UDP client.c. Let me write the name as UDP client, CLIENT, user datagram protocol, UDP. Without any connection, communication will be there. Okay, so these two files are ready, and now let me start the coding. Let me tell you, the server will run indefinitely, and client will send the message. Server will see the message and send the acknowledgement. This is what program will run. There are certain include files which we need to include. Hash include. This is stdio.h, standard input output .h. In C we require it. So all this program will have this file. Now I'm copying and pasting it. I'm just changing it, right? So the second file would be, and there are other files also in various programs. If you go to the internet, you will find different files, but they may not be required. These are the basic required files. netdb.h, this is definitions for network database. Next file is, this is the third file, sys/socket.h. sys/socket.h. This header shall define the sock adder structure that includes at least the following members, which are SA family address. So this is having the all sock ADDR is the basic structure. Sock ADDR, this is the most important thing. Sock ADDR is the basic structure, which will have all the socket information. Okay. Now the next one is sys types. For different types we need it. Then we have net/in.h. In this file, this header file contains definition for the Internet Protocol family. That is, this header shall define the sock ADDR_in. Sock ADDR in socket.h, and this sock ADDR_in So we have basic sock.addr, this controls everything, but we have to make ourselves sock.addr because this is a better way to access the elements which are in sockets. Then we are going to typecast it to the sock.addr structure. I hope you got the idea. Sock.addr, then sock.addr underscore in. We are using sock underscore in, not sock.addr, but we are going to typecast it because sock.addr is the actual thing. So we'll use a while because datagram server is going to run forever. So if you don't want to make it as while, just remove that while which is coming down. Now I'm creating a function which is called an error. Now this is not an important thing with respect to this program, but still, because in network there can be various errors. Machine is not working, host is not properly open, or there is network problems. All these things we have to deal. A good programmer has a good this error handling capabilities. So this is void print error. This p error I'm writing here, and this is a POSIX error function, p error. This is used in C and C++ to print an error message to stdio, standard error, based on the error state stored in ERRNO, error number. Okay, exit, it goes out of the program. So p error is the POSIX function, which the print error is our made. This is self-made error function. P error is the main thing which is inside here. So we just created it for our ease. Now the input will be through command line. We are not going to hard code it. We are not going to give hash defined port as 4457. No. We are going to give it when we run the program. We are going to give the actual thing there, not hard coding at all. And the UDP client will also be having these arguments. Argc is the argument count. Argv will have all the content, means you give 3, 4 like this. So we will have certain variables you will come to know just shortly in a while. Sock is the basic thing. Sock, you'll just know length, fromlen, and comma n. So sock, these 4 are there. You'll know how we are going to use it. Now the most important thing, most important thing, this is the heart of this program. Struct sock.addr underscore in. I told you sock.addr is the basic structure, but this structure, this underscore in, these are the basic structure for all system calls and functions that deal with internet addresses. In memory, the struct sock.addr underscore in is the same size as struct sock.addr, and we can freely cast the pointer of one type to another without any harm. Okay, this sock.addr underscore in is what we have made, but basic is sock.addr. So there is always a possibility to typecast them. Okay, change the type. So we can do that. Now we have a buffer. We have buffer. BUF I am giving, just see in the coming program whether I am writing BUF and BUFFER, because I do these mistakes, quite common. Now this buffer can be 1024 size. Now the program is running. We have to first check the user has given the actual inputs or not. So as I said, 2 inputs will be there. First will be the program name. The other will be the port number. So if the user is not typing the port number, it has to tell. The program has to tell that, okay, please give all the information we require for this program. For that, I am just writing, if argument count is less than 2, we need at least 2 of them, or actual 2 of them. So we'll just write fprintf stder, standard error this is. And then we have some, you can write anything here, error, no port provided, like this. Now this fprintf is used to print content in file instead of standard console, standard out console, std out console. So fprintf you can write, or whatever you want to write, it's up to you. These are not the network stuff we are discussing. Okay, now you can have exit 0. Now coming to the second important part of this program, second important part, which is sock. SOCK, mean most of the program in the internet you will see SOCKFD. So you can write SOCKFD or SOCK equals socket. We are opening the socket. The socket function shall create an unbound socket in a communications domain and return a file descriptor that can be used in later function calls that operate on sockets. So there are three things. There are three things here. AF, INET, AF, address family for internet, AF, INET, sock, dggram for datagram, for UDP. If I write sock underscore stream, that will be for the TCP. Okay. 0 means take whatever you want, means choose the best one. These three things I hope you understood. Socket opening, socket description is the main thing. Okay. Now you can also have error checking here. Error checking. So if sock is less than 0, you have to handle this error. So just main thing is you have to understand this socket, what we have done, and this will return a file descriptor which will be stored in SOCK. SOCK will have the socket return file descriptor. That SOCK we are going to use again and again now on. Okay. So that this is just a handling. If socket doesn't open or there is a problem, then this is the error handling. I would request you not to go deep into the error handling part right now, though you have to. Main thing is struct sock addr in, then opening of the socket. Okay. Now socket we have opened. Now we have to fill them up. So in order to fill them, let us do some pre-task activities. That is, so this size of operator we are using for server, and this size of operator is a much used operator in C and C++. It is a compile time unary operator which can be used to compute the size of its operand. So we created sock underscore in server. Now I am putting it here, and I have to clean it. Let us clean it. So what we will do, we use B0. This B0 function erases the data in the n bytes of the memory starting at the location point to by the first, that is S, by writing zeros, that is byte containing /0 to the area. In a nutshell, we are cleaning it, we are clearing it. Ampersand server, we are cleaning it. Okay. Size of that server, that is the structure, is known, and the cleaning of that particular structure is also done. Two things are done. Now, as I said, a socket will have three things. What is the family, what is the IP address, and what is the port. Three things. Important thing is three. So I am just writing these three things we are putting it here. Three things are important. First thing is this server.syn family. The first is AF underscore INET. AF INET refers to the addresses from the internet. IP addresses specifically. IP addresses we are going to deal with. Okay. If you write PF underscore INET, this refers to anything in the protocol, usually sockets and ports. So best thing, because we are dealing with IP addresses, internet, let us have AF underscore INET. AF underscore INET. Okay. So I am going to give this syn family as AF underscore INET. Second thing is server, that is the IP address, you can say. AF INET is okay, IF INET. Second thing is in.addr underscore ne. This in.addr underscore ne is used when you don't need to bind a socket to a specific ID. When you use this value as the address when calling bind, the socket accepts connection to all the IPs of the machine. So we just made it freehand. Coming to the third part, which is now we have third, that is the port number. This A to I function in C language converts string data type to integer data type. What H2NS is doing, H2NS function takes a 16-byte order number in host byte order and returns a 16-bit number in network byte order used in TCP/IP network. That is AF INET family, address family. The h2ns function can be used to convert an IP port number in host byte order to the IP port number in the network byte order. I hope you got the idea. Come on. Coming to bind. Now bind. I showed you the diagram also. Socket we opened, 3 things we fitted in the socket and means linked with that socket. Now bind. After creation of the socket, bind function binds the socket to the address and the port number. Address and the port number, IP and the port number. Because what is socket? Socket is nothing but address and port number, IP plus port number. So I'm binding it. We have opened a socket, SOCK. Yes. Now, what is the server? You know it is a structure. It has all the content inside this. So we, as I said, sock addr underscore in we have created. But the basic thing is struct sock addr. So we have to typecast it. This is what we have made. But as I said, struct sock addr is the basic thing. Because this is only which we are going to deal with. But we have created that server, server. So we have to take the ampersand and we have to typecast it. Is it okay now? Now coming to length we have already taken size of server. And if, let us check it here only. If it is less than 0, just put as some error. Just put some error. Error, say binding. Error in binding, like that. So as I said, now you can put an error. Let me tell you again, bind is what? After we create the socket, bind function binds the socket to the address and port number. This SOCK, then sock is what we are dealing with. Then we have struct sock addr. This is what we are going to deal with, but we are making server, so we have to typecast it. Length is the size of server. Now coming to the from length. Now we have taken the size of what? We have just typecasted it. So let us take from length. Now the server is getting something. So we have to have a size. So we have 2 things. We created 2 structure. If you remember, one was server, one is from. So now take the from. So now we are saying the from length equal to size of sock addr underscore in. Now while one means infinite loop. Server is always going to listen. Server is always going to listen because now it is receiving it. Server is going to receive it. So we will use the function. As I said, there is no listen, there is no accept, there is no connect here. So we have receive from and send to, receive from and send to. So receive from, what are the parameters? Sock, of course, sock will be always the first parameter. Buffer, buf, I created 1024 is the size, comma 0, and then now what we'll do here? We will give struct sock addr. We have to typecast it. But now which structure element? Structure variable. As I said, from, right? We will take this, but not server. We are going to take it as from. I told you 2 structure I made. One was the server. One, what is this? What is things coming from? So I am going to change not server but from, okay? Not server, from, because receiving from somewhere. And of course we have from length, ampersand from length, because earlier also we said we gave the length. Now from length also we are going to give from length. We have just found out the fromlen, fromelen. Now you have to use an ampersand here. There is a, okay, you have to use an ampersand here. So just write a ampersand. I didn't write it, but you have to have a ampersand here. Now let's give the error checking. Let me tell you again about this receive from. The receive from function shall receive a message from the normally used in connectionless mode sockets because it permits the application to retrieve the source address of received data. It specifies the socket file descriptor. I hope you got the idea, or let me tell you again. Receive from function in connectionless mode sockets, we use it because it permits the application to retrieve the source address of received data. Okay, now some error checking I'll do. So this is the error checking, some if n is less than 0. Okay, so this is an error checking. Now coming is to write. Now most of the thing on the internet you will see fwrite or another way of writing it. So I'm just write, I'm using it write. Two writes here. This write, let me tell you what is write, what the write is. Write system call writes data in bytes as specified by the caller from a buffer declared by the user in the program and then writes it into the file supplied by the calling process. Right? So we'll take 1 comma received datagram comma say 30 or whichever size you want you can give. Okay, here the size can be what maximum you allow that you can give, but here as I said, the write system call writes data in bytes as specified by the caller from a buffer declared by the user in the program and then writes it into the file supplied by the calling process. I am writing write again 1 comma buffer is what? If you send, if you receive, you have to put it somewhere. So this buffer is doing exactly that. Comma n. What is n? N is what? N is the descriptive. N is the return of receive from. Receive from function has returned something. We took it on n. Now I write it n. Now coming to send to function. This send to function is normally used on a connectionless socket to send a datagram to a specific peer socket identified by the to parameter. Even if the connectionless socket has been previously connected to a specific address, this parameter overrides the destination address for that parameter datagram only. So now send to, same thing I am writing, but I am going to change it. I am going to change it. What? First is sock. Sock will remain like this. Buffer, buf, it will be like this. But in this buff, you are sending the message. The server is sending the message. So you have to put a message here. Okay. You have to put a message here. Say it's some message received or got your message, received your message. But whatever you're writing, you have to count this. Count this RECEIVED, count them. Because you have to put a proper number here. Okay, sock, comma, received your message. From where it is coming, we are sending it there only. The send to function, as I said, is used on a connectionless socket to send a datagram to a specific peer pocket identified by this parameter. Even if the connectionless socket has been previously connected to a specific address, this parameter overrides the destination address for that particular datagram only. So I gave 22 because I counted from R2/n. 22. Very important. Exactly number is given. Again, from you know, then from length also you know. This struct sock.addr, you have to typecast it. Ampersand from length. Now let me do some error finally. Okay. This I hope you got the idea from receive from and send to. Receiving is from receiving from the link which has not been established, but you know that port and IP number, so you can establish a link. And then finally send to. This send to and receive from. Oh, okay, all that thing is done. Fromlen you have to put an ampersand here. So there is a change. Okay. And the server is ready now. Server is ready. I am just copying it. I am going to paste it in the client. So let me just give you a test run. How it's gonna run. I'm going to run it. So whatever we have changed, let me just show you here. So this will be the file name is UDP server.c. So how are you going to run it? GCC UDP server.c / oh, there is one more change. See this 48 line. You have to put a struct here. Okay, there is a change. Please make this change in your code. Struct. And second thing is ampersand. Two things you are going to change. Now GCC UDP server.c / this -o server. This file there with this just warnings will come. Don't worry about that. But the error should not come. the red lines will be showing the error. So now you just run this ./server 4457. This is how you are going to write. First is the parameter of the running file. Second is the parameter which is the port number. So these are two argument argv. So the argc will be 2. So when you compile this, means you run this. So now it has started reading. It is started because it's in an infinite loop. ./server. You see there is error because I haven't put the port number. You gotta put the port number. So we have checked the error also. So you have to just say ./server 4457 or any port number you can give, and just press enter. It is going to run, and I'm going to close this. Okay, I'm not going to run it because I'll do it at the later part when I actually write the client. First we have to start the. Okay, now let me just take you now again here, and as I'm saying, I'm copying all the content of the server file and copying it to the which point? A file of, if you remember, UDP client, we have already made it. So UDP server.c done. I'm opening UDP client now. This file is okay. Let us copy this content, and just paste it here in UDP client.c. Just these are now the same program. Now I'm going to edit here. Because why I'm pasting it? Because I want to show where are the changes. What are the changes you are going to make in UDP client? Okay. So this stdio.h is already there. Then we have 2 more files. stdlib, standard library file, you have to add. Then string.h you have to add. String.h. So stdlib.h and string.h you can add. And all others are there, but one more we have to add. Socket types net in./in netdb was already there. So I gave you all the discussions also, explanation of these files. Now one more thing I'm adding, which is the arpa/inet.h. arpa/inet.h. This header shall define the inet addr strlen, and for the IPv6 inet6 addr strlen macros. These are described in netinet/in. So whatever there is in netinet/in, in order to, this header file defines the other stuff which are macros which are defined in the previous file. Okay, now let's change this also. UDP client in the internet space. This is a client program, UDP client. Let us say that this is internet af_inet we use so many things in the server, so it is clear that we are working in the internet domain, TCP IP domain. Okay, most of the things we have already discussed. So error we have already written, argc, argv. Now here user is going to give 3 parameters. 3, when he writes in the command prompt, 3 things the user has to give. Now sock length n is there. So there are other things, I am deleting it. Sock length and l is there. 2 structure we are making, server and from. 2 server I am making, server and from. See, sock addr_in we are making because it is easier to access all the 3 contents of the socket. But sock addr is the basic thing. So we will convert or typecast sock addr_in to the sock addr. Now this is one more thing. This host ent. Now this host ent, we are going to use a function called get host by name. So this we are going to use later. That is why we have a structure, host ent, host addresses, host ent are always given in a network byte order. We can use this host by get host by name, by address, in order to get the information from the proper host. That is why host ent is there. Now buffer 512 is there, 256 also you can take, 256 also you can take. Now argument are 3 here, as I said. First is the file name we are going to run. Second is the IP address, because we want to run this program same in the client and server in the same machine. We are going to going to give local host. But if you want to have some other system connected, you have to give that particular IP, okay, or that system name, because we have used this get host by name. So, and the third thing will be port number, same port number which the server is listening to. Okay, now these three are this error check is done. Now socket. You know this socket now. AF inet socket dgram 0. We have already discussed this. If socket has some error, it is okay. Some error will be there. Now AF inet for the address family for internet, and as I said HT I gave HT. So this will be HT equals get host by name. Get host by name. Many things I am deleting it. Let me delete it. I am going to give only those things which are required in the client. So I just deleted that line. Now server SIN family we need it. AF underscore inet. This should be here. Now what about the IP address? So as you know, as I said, in the command prompt you are going to give second parameter as the IP number, IP or host number, host name. So that host name will use a function here, get host by name. Get host by name. So it will extract, it will get the IP address from there. So get host by name. If you remember, I created a struct host ent. So this will be get host by name. So get host name function retrieves host information corresponding to a host name from a host database. Get host by name. So we already have this function. We don't need to give any specific address. We'll extract our IP from here only, HT. Now two things are done. Now we have to extract the address also. So let us use, now if HT has some problem, so let us say that the information is not there. So this is error checking for HT. This is also done. This is error checking. Socket opened, then server.sn family if inet we gave, and the first parameter that is you are going to give in the running of the program, that will be the local host, and we are going to get the host by name, and HT will handle it. Now we are going to have bcopy. Bcopy function copies the byte string pointed by the source into the array pointed by the destination. First content, second content. Just remember first parameter, second parameter, what is here? I am giving it. So it's giving, we are taking the address. You know that this HT will be having the host address, IP address. I am taking the address from HT pointer. So HP, we can use an arrow operator for accessing the h underscore addr, and also we can have the SIN addr and also the length. So bcopy is from transfers one to another. So we have, this is the first thing, this is the character pointer we typecasted it, HT arrow h addr, and we are going to, as I said, this function copies the byte string pointed by the source into the array pointed by the destination. So we have this char star ampersand server here, and you know that we are dealing with that server dot SIN. Now what is here? As I said, three things are there. SIN family is already done, SIN addr is not been done, and this is the SIN addr. SIN addr, the address is also done, and you have to give the length also. So HT arrow h underscore length. So now we are done with the AF underscore inet, we are done with the ADDR address also. Okay, so I'm deleting this line also. Now third thing is remaining. See, the protocol is done, the IP address is done. Now port number. So we know how to do the port number. The third thing in the command prompt will be the port number. So as I said, H to NS, what it is going to do, A to I function, what we'll do. Now we'll use the argv2. Now the third thing which the user is going to type as the port number, it will take and put it in the port, SIN port. This is done. Three things of the socket are filled. Protocol type, the IP address, and the port number. Done. Now we are going for the send to and receive from. For that, let us do the pre-activities. B0 function we are going to use. B0, you know what we do. It will make all the zero buffer. Say buffer. Don't see the things which are written below because I just copied it. I'm going to delete them. Just see what is above. Now, oh no, one more thing. We need to ask the user what message you are going to write, because we want to send this message to the server. So let us say printf enter message. Now this server will ask us that please give the message so that I can transfer it to the server. So print error message. It will ask for the message. So let me clean that standard in and buffer also. For that, just do B0. In the buffer there can be previous thing also, and we always clear them before dealing with them. So it's always a good idea. B0, and then we have buffer, comma 256 or 512. This 512, okay, and you can just change that 512 to 56, it doesn't matter. Now fgetS function, this read text from the standard input, not from the keyboard directly. So the value returned by fgetS is the string that was input. So now we have fgetS, take buffer, comma the length, and say you want to get it from the standard input. So stdin you can give. So now user has the client has asked for user to give the message. We will give the message. This will get it in the buffer through fgetS. Now I'm all deleting it. I'm deleting it. Though we have this receive and send function, but I'm just deleting it. So this is done now. Okay, now coming to stdin, I've given fgetS because we want it from the input, from the standard input. It generally doesn't do it. So n equals to send to. You know what all we are going to give? Send to what? You are sending it to the server. You are sending it to the server. So sock buffer strlen buffer comma 0, and here ampersand server. Ampersand server you have to give. So you have ampersand server here, comma length. Length we have already taken. Okay, length. So this is server length. Server comma length. Now let us check error. But now you have to see send to. Let me tell you again. It is going to the server. It is going to the server. That is why ampersand server. And then the second thing is receive from. Now, as I told you, in the server we have written some acknowledgement also. So the client will be receiving it also. It will be receiving also. So the send to will send the content to the server. Receive from will receive the content from the server. Okay. So receive from, we have this send to is done, and there will be some error checking. After send to and after receive from, always do the error checking, because these are the functions, because we have many parameters inside this, so it may create some problem. Always do the error checking. So send to and receive from. Okay, it's if n less than 0, this print error send to, or you can write any other thing. Now coming to the receive from. N equals receive from, RECV from. I'm just copy paste and I'm just editing it. Receive from. SOCK buffer. Now this is strlen buffer. You can give the size 512 or 256, whichever you want, comma 0 and ampersand. What is ampersand? See, it was from. Now client is getting it from somewhere. From, just make it from, because it is socket.h underscore in only. Ampersand from, and of course length. Pass the address. Make ampersand here. You have to make ampersand. Let us do some error checking also here. And if you remember, we gave what? We gave 2 writes. So you can write 2 write also here. 2 writes. It will be write, say received an ACK or got an ACK, you can write. And the other one, buffer, receive from. Okay, so write, I'm going to write 2. So write 1, comma. Now here what I'm writing, you have to count each character and exactly those number you have to give in as the end parameter. So you say received an ACK. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So you have to count and that number you have to give here. Okay, let me count it again. So it's 17 only. Okay, 17 is there, and then exact number you have to give. Then second one is write again. If you remember, we wrote it in the server program also. So 1, comma buffer, comma n. Okay, 1, comma say buffer, comma n. So almost this program is completed here. Client also we wrote, server also we wrote. Now let us run them. Let us see some error checking we can do if there is any problem. I'll give you the code in the description, so don't worry about that. Okay, now okay, I can see that things are good. Buffer. As I said, I always do this mistake. BUF-FER is there in the, so just change it. Always give buffer, BUF-FER, whatever you have. You can just recheck it. So I've just changed it to buffer. Because wherever it is BUF-FER, just change it to BUF-FER. Here also you see right. Now this Control C, save it. Control S you can give. Now we have these 2 files ready. Okay, now open the terminal here only. Come to here and open the terminal. You don't have to do that cd back and cd dot whatever those commands are. Come running the server. GCC UDP server UDP server.c. Last server I just closed it. Okay, UDP server.c and then -o. Give some file name. Say it is server, and now this file will be made. There will be some warnings. Don't worry about that. Only the out file should be made. Means the executable file should be made. Binary file should be made. Now /server, 2 parameters you have to give here. /server 4457. Any port. Now the server is listening. Server is ready listening. Okay. Now let me just make it visible because I want to run the client and server together. So now I'm opening terminal from here only. Same folder, and just give GCC and UDP client I'm running. So let me just compile it, make a binary file, then we'll run with the three parameters. two parameters actually. One will be this file name only. So it will be gcc UDP client, gcc UDP client .c hyphen or dash o output for output. Then give the file name as client, say client. You can give any name here, client. So enter. Some warnings will come, don't worry about that. There should not be any red line, right? Don't worry that. Now ./client. Now what you have to give? Two parameters, local host. You can also give a IP also. Local host and IP also. Then you have 4457, right? Now it is asking enter message. Enter message. Now you are going to just see below. Just see below. I am giving this message. It is going to go to the server. See, this hi server has come to the server, and it has also given the acknowledgement. Received your message. Received and acknowledged. Okay. Okay. This is done. This is how you are going to make. Thank you so much. Take care of yourself. Okay.